So our example of projectile motion. A golfer hits a ball off the edge of a 380-foot tall building. 380 feet tall. Its initial speed, the ball's initial speed, is 112 feet per second. We want to answer some questions about this ball, how high it is above the ground and whatnot. But first we need an equation. Remember, our functions are always of the form -1/2 at squared plus v naught t plus h naught, where a is the acceleration due to gravity, v naught is the initial speed, and h naught is the initial height, the starting height. The starting height, 380. We're on the edge of a 380-foot tall building, so that's the initial height. So that's going to be 380. I'll erase that and put it in. The initial speed, 112. 112 feet per second. So we have 112 t there. And because both of these are measured in feet, the value for A will be 32. And so -1/2 of 32 is -16. And so my equation that gives me the height as a model of time is -16 t squared plus 112 t plus 380. Now, a good first place to go whenever you have an equation like this is to graph it. Figure out some graph, some window that will give you a picture to see the whole ball's path, the ball's entire path. It can take a little bit of time to figure out exactly what the values for the x-min, y-min, x-max, y-max should be in the window of your calculator. Go to the table, hit second graph. To bring up the table, look at the x values, look at the y values, figure out when does y stop increasing and start decreasing, because right around there, that should be your y max. Your y min should be 0. Your x min should be 0, since obviously we can't go underground, or, well, I shouldn't say obviously. We're not going to go underground here, and I don't care about negative time. That's not really a thing. Eventually, the graph will go below the x-axis, and so wherever that happens, that's going to be where you want to put your x-max. This will be a good way to get a picture in your mind, as well as on a piece of paper, of what exactly is happening. Now, there's a few questions we might want to ask about this. The first question I want to ask, question 1, when will the ball hit the ground? When will the ball hit the ground? So the first question is, what does that mean? What does it mean when the ball is on the ground? Well, how far above the ground is it if it's on the ground? What's its height if the ball's on the ground? Be 0. And so that's going to be the key thing here. The height will be 0. And everything else is unchanged. We're going to plug the height in for the height part. And I'm going to solve for t. I want to find the values of t for which this equation becomes 0. So I do this by factoring. We'll go through the process. First, take out a GCF. Might take you a moment to figure it out here, but here it happens to be 4. And I'm going to take out a -4. I don't know if your teacher in class has mentioned this, but if the leading coefficient term is negative, you should always take out the negative. Here especially, because that's always going to be negative. When we're talking about projectile motion, this thing's always going to be negative. After all, what goes up must come down. Gravity is always going to be winning in the end. You try to go up in the air, gravity is always pulling you back down, so that's always going to be negative. I'm going to take out a -4. That leaves me 4t squared minus 28t minus 95. Now I can split the middle. I want two numbers that multiply to 4 times -5, so -380, and add to -28. Two numbers that multiply to -380 and add to -28. It's going to be 10 and -38. Negative 4 doesn't go anywhere. I have 4t squared plus 10t minus 38t minus 95. Negative 4. You can take a 2 out of both of those, 2t even. 2t plus 5. I can take out a 19 out of those two terms. So minus 19, 2t plus 5, which gives me a finally factored form, a fully factored form. I'm going to erase some of this stuff so I have more room to work. A fully factored form of negative 4 times 2t plus 5 times 2t minus 19. That's my factored form of the original equation. And now I can set these factors individually equal to 0. 2t plus 5 equals 0 means 2t equals negative 5 means t equals negative 5 halves. Or 2t minus 19 equals 0, so 2t equals 19, so t equals, what, 19 halves. Negative 5 halves, that's the same thing as negative 2.5. 19 halves, that's the same thing as, what, 9.5? 9.5? I think 9.5. Yeah, 9.5. Back to the question, when will the ball hit the ground? Well, remember, t is measured in seconds. So the answer is either going to be negative 2.5 seconds or positive 9.5 seconds. Always pay attention to when your answers make sense. Does it make sense to have an answer of negative 2.5? No. So the answer then we want is 9.5 seconds. When will the ball hit the ground? After 9.5 seconds. That's your answer. We can use this principle, we can use this procedure of factoring and looking for the zeros anytime for any height. Here we're asking where the ball hit the ground, but if we asked as question 2, when will the ball hit, come back to 380 feet maybe? Come back to 380 feet. Since after all, you're hitting it off the edge of a building, it's going to go up. And eventually it's going to come back down to that same height. And then it's going to keep going down to the ground. If we go back to the original equation, now we want a height of 380. So 380 equals negative 16t squared plus 112t plus 380. It doesn't have to be 380 over here. It could be whatever height you want. Absolutely whatever height you want. Sometimes this won't work out as easily for certain heights, though, so you do got to be careful. Pay attention to what the question is asking. In this case, as in any case, I solve for 0. Subtract 380 from both sides. I get 0 equals negative 16t squared plus 112t. 380 minus 380, they cancel each other out. Factoring now, negative 4t times what is that? That's 4t plus, minus rather, because I'm taking out a negative, minus 28. 4 isn't the greatest common factor, is it? No, I think I could take out a whole 16. Yeah. I could take out a whole 16 from there. Negative 16 t. T plus or minus 7. It's after 7 seconds. It'll take 7 seconds for the ball to reach that same height. 380 feet again. Whenever you're asking a question of when will it reach a certain height, you're looking for t. So the height you'll plug in over here on the other side of the equation. If it's 0, if it's the ground you're asking about, plug in 0. If you're asking about how high it'll be at a particular time, then it's just a matter of plugging it in. If I wanted to know how high will the golf ball be after 2 seconds, just plug in 2. Negative 16 times 2 squared plus 112 times 2 plus 380. Just type that into your calculator, you can get out the height.